It's basically a video how final executable firmware is being created. We will start from the C code where we write some C code, and then compiler and assembler how basically C code converts into zeros and ones, basically a machine code. How it happens is basically through compiler and assembler. In compiler, what happens, you have C code where there are variables, and there are like basically integers and like numbers, strings, all of those things. These are basically syntax. The syntax is basically break down all those variables, strings, integers, and many other data types into tokens. And what happens next is basically then we need to categorize or arrange these tokens into some data type, into data format basically. So it basically represented or arranged or categorized into abstract syntax tree. And this abstract syntax tree, now many abstract syntax tree are created. For example, if there is var1 is equals to 2 plus 2, then this whole statement is saved into one abstract syntax tree, and this abstract syntax tree is saved into register. And what happens, you have got assembly code. Now uh, this and now you have this, and now you have basically many object codes. What are they sorry, now you have many assembly code. Okay, now what happens is basically compiler type decide what architecture to follow. What architecture to follow means every controller has some instruction set, and depending on the type of controller, it uses specific instruction set. And why it follows that instruction set? Because there are only few architecture is being followed depending on which instruction set is created for that particular controller. Now what happens is that this is like you have many object codes, and these are basically or sorry, now you have many assembly code basically. And assembly code is specific to a controller. Okay, object code and assembly code is specific to a controller. Now what happens, you have many object codes, because when you are writing a code you are importing many libraries, and thus you have many object codes. Now what happens, these object codes go into the linker. What linker does is basically combining all those libraries and functions. Like for example, you use a math library. What it does is it basically catches that library or function, or basically glued all those things into single final executable firmware. So this is how the firmware is being created. Correct me if anywhere I am wrong. This is what I understand, like how different basically different like same C code is basically used, and you can create for many different type of controllers, like for ARM, for x86, and for and native compiler. So it's basically all depend on the compiler. Depending on the type of compiler, you would have a specific object code, and that specific object code would have obviously a specific assembly code which is designed for a specific controller. And it is due to the fact that there are only few architecture, and those few architecture dictate the specific instruction set each controller used. Due to that, the compiler are designed in this way. And now you have all of those information. Now basically you have many object files. Many object files means each object file represent each function. So you have main, you have one object file, and then you have math library you use, and that is another object file. So these are basically object files which can run on the specific controller, but we cannot run three object files separately on a controller, it basically need to be glued by a linker is basically glued them together, and now you have final firmware, executable firmware. So this is how basically controllers run a program. Woohoo! Bye bye.